This is a second video in the series of revision for class 9th NCERT science. Second chapter is about is matter around us pure. In first chapter we discuss about the matter, state of matter, and how the state of matter can be changed, and the change we were changing on the basis of uh, the distance between the constant particles. We are changing by two way, by applying pressure or by changing temperature, changing pressure and temperature. So in the continuation, now we're going to discuss about is matter around us is pure. Let's discuss what he meant by pure. It's just a revision video. It is not it's just revision video. Milk is actually mixture of water, fat, protein, etc. When the scientists say something is pure, it means that all the constant particles of that substance are same in their chemical nature. So in the constant particles like atoms, molecules, ions are same throughout the substance. This is pure. A pure substance consists of a single type of particles. And what is unpure, we call it mixture. Like in mixture there will be, therefore we can say the mixture contains more than one pure substance. That means if the constant particles are not same, they can be two, they can be three, they can be four and more, then that substance is a mixture. Type of mixture we have, it doesn't have anything in this. Depending on the nature of cross components that form a mixture, we can differentiate mixtures. Difference, we have a different type of mixtures. There is activity. I have to read this activity, which I don't want to. Now we can learn about the solution, suspension, and collision. Okay, let's move ahead. I can simply tell you there are two types of mixture. One is homogeneous, one is heterogeneous. We may discuss this later. Homogeneous means the constant particles, the different constant particles are mixed homogeneous throughout the whole body. And heterogeneous mixture, uh, they are not same. Like the example of homogeneous mixture is like salt and water and sugar and water, and heterogeneous mixture is a soil and water. The soil over the time, if left over, settle down, and water will remain above. So this is heterogeneous mixture. It will be there in the in the chapter, but let us discuss this. Okay, now what are solutions? A solution is a homogeneous mixture of two and more substances. So solution is a homogeneous mixture. We just discussed the mixtures, and two types of mixture, homogeneous and heterogeneous. A solution is a homogeneous mixture of two and more substance. Uh, in a solution there is a homogeneity in at all the particle level. For example, lemon taste the same throughout. This so that the particles of sugar or salt are evenly distributed in the solution. Alloys, what are alloys? Alloys are the mixture of two and more metals, or a metal and a non-metal, and cannot be separated into their components by physical method. We need chemical methods to separate these, but by not physical methods. Brass is a mixture of approximately 30% zinc and 70% copper. So there is one more concept. Solution is made of two things. Like solute plus solvent is a solution. Solute is what is added, and solvent is on which we are adding. The component of a solution that the component of solution that dissolves in other component in it, usually the component present in the larger amount is solvent. Solvent is a larger amount. So there is a trick. See, solvent has a 1 2 3 4 5 words, and it has only 4 words. The 5 is more larger. So solvent is something which is present in larger amount. A solute, it has a 4 words, so it is a less than. This is a trick to remember. The component of the solution that dissolves in the solvent, usually present in a lesser quantity, is called solute. Properties of solution. What are the properties? First, as we discussed, by definition, a solution is a homogeneous mixture. That means the different components, maybe atoms, molecules, whatever the solution contain, should be mixed properly, that there is a homogeneity in it. That means, like, we cannot, like, physically separate uh, the particles. They are means, like, you just take a part of it, and suppose the 10, there's a mixture of a, the ratio will be same. Suppose we have a 1 or 2 ratio of a milk, sugar and water. If you take 1 spoon of from it, the ratio will be again 1:2, sugar and water. So that in everywhere the ratio will be same. So the particles are mixed thoroughly, that there is a homogeneity. Homo means same. uh, because of the very small particle size, they do not scatter beam of light passing through the solution, so the path of the light is not visible to the solution. And also in the solution, when we pass a light, the path do not become visible. Why? The path only becomes visible uh, when the light scatters from the particles. To scattered light, the particles need to be bigger in size. Only then it can scatter. If the particles are small, and light wave cannot scatter. Light wave cannot scatter it, so it needs a bigger particles or molecules, so light can scatter. So because of the small particles, they do not scatter beam of light. Small particles, okay. And the passing through the solution, okay. The solute particles cannot be separated from the mixture by the process of filtration. The solute particles do not settle down when left undisturbed. That is, a solution is stable. We already discussed. The particle solution is smaller than the 1 diameter, so that they cannot. Okay, they cannot see in the naked eye. This is a simple one. Concentration of a solution. At any particular temperature, the solution that has dissolved as much as solute as it is capable of dissolving, it is said to be a saturated solution. The amount of solute present in a saturated solution at a temperature is called its solubility. What is solubility? The amount of solute present in saturated solution. Saturated solution is the solution which dissolves as much solute as it can dissolve. So at this temperature, the amount of a solute present in the saturated solution at this temperature is called solubility. What is a suspension? Non-homogeneous system. See, solution was a homogeneous system, homogeneous mixture, and suspension is a non-homogeneous mixture. That means the particles are not mixed properly in a everywhere, in which the solid are dispersed in liquid are called suspension. A suspension is a heterogeneous mixture in which the solid particles do not dissolve but remain suspended throughout the bulk of the medium. The particles of the suspension are visible to the naked eyes. Properties of suspension. Suspension is first heterogeneous mixture, then can seen through naked eyes and scatter beam of light and make it path visible, and particles settle down. Okay, when suspension is left undisturbed, and that is a suspension in unstable. So everything is opposite in the suspension, and we compare it with the solution. Now, what is a colloidal solution? The particles of a colloid are uniformly spread throughout the solutions. Uniformly spread means this is a homogeneous type thing due to the relatively smaller size of the particle as compared to that of suspension. The mixture appears to be homogeneous, but it actually a colloidal solution, a heterogeneous mixture, for example milk. This scatters beam of light. It's called scattering of Tyndall effect. So, what is colloidal solution is like the particles is appears to be homogeneous, and why? Because of small size of particles, and not even smaller than the as small we find in solids in solutions, and particles are large enough to scatter beam of light. Tyndall effect can also be observed when a fine beam of light enters in a room through the small holes, and this happens due to the scattering of light by the particles of dust or smoke in the air. The path is not visible, that is, this is solution, and this is a colloidal solution. Colloidal solution, okay. So, difference between suspension, colloidal solution, and a solution is the particle size. Depends on particle size, and the particle size is deciding uh, the homogeneity, whether the solution, whether the ratio of the solution is remains same throughout the thing, or it changes with the particle size increases. The big size particle going to settle down, so it will remain suspended. So Tyndall effect can be observed when the sunlight passes through the canopy of dense forest. In the forest, the mist contains tiny droplets of water, which acts as the particles of the colloid dispersed in air. So we can see the light waves are visible. Why? Because there is a particle of water, and water is acting as a colloidal solution. That means when light is coming, the water is scattering the lights and making the path visible. Properties of colloids. A colloid is a heterogeneous mixture. It looks to be homogeneous mixture, but it is actually a heterogeneous. Why? Because its particle size is large and it scatters light. The size of particle in a colloid is too small to be individually seen by naked eyes. We cannot see the the particles. Colloids are big enough to scatter a beam of light passing through it and make the part visible. We cannot separate from we cannot separate from the mixture by the process of filtration. So colloidal solution cannot be separated by filtration by physical methods, but special techniques of separation known as centrifugation can used to separate the colloidal solution. Centrifugation is like centrifugal force. When you rotate it, due to centrifugal force, like heavy particles uh, you know get more force and they goes in outer area and small particles remain inside. Common examples of colloids: mm, aerosol, dispersed medium, dispersed phase. In a gas, if we just discuss this example here, this is aerosol. Liquid is mentioned as milk and face cream. Solid soul. Smoke, automated exhaust gas. Separating the component of mixture. Homogeneous mixture can be separated into their respective, sorry, heterogeneous, heterogeneous mixture can be separated into their respective constituents constituents by simple physical methods like hand picking, what is this, sieving, filtration, that we use in our day-to-day life. So heterogeneous mixture can be separated by physical method, and the homogeneous cannot be separated through physical process. It can only be separated by chemical. How can you separate cream from milk? Mixture of, so this was the crux. uh, the process of separation of a component of a mixture is known as chromatography. Chroma means color. Application: to separate colors in a dye, pigment of natural colors, drugs from the blood. How can you separate mixture of two mixable liquids? Through distillation. Separation of mixable liquids by distillation. It works because the difference in boiling point. Boiling points is different, so we can, by increasing the temperature, first those particles which have less boiling point will get evaporate, and only those particles can be so again liquefied by cooling it. So we can through chemically separate these. This method is called distillation. It is used for separation of the components of a mixture containing two miscible liquids that boils without decomposition and have a sufficient difference in their boiling points. How can we obtain different gases from the air? Again, air contain multiple things. We will compress, cool by increasing the pressure and decreasing the temperature, liquid air will form, allow to warm slowly in fractional distillation column. So air can be separated. See, oxygen, like liquid oxygen will evaporate at this temperature, argon at this temperature, and nitrogen is this temperature. So that means first nitrogen will evaporate, then argon, then oxygen. We can separate. This is why we can separate gases also. But this is gonna be very difficult because the temperature difference is very low, very less. So slowly is there, slowly warm up slowly. Separation of component of air. This is the same thing. This is a practical thing. Air in, then hot air is there, compressed air, separator, carbon dioxide, liquid. So like at different temperature, this is the application of this. How we can separate by like regulating the temperature. Water purification system. Reservoir in this. Chlorination to kill bacteria. We use chlorine to kill bacteria. Physical and chemical changes. In the previous chapter, we have learned about the few physical properties of matter, that the properties that can be absorbed or specified, like color, hardness, rigidity, fluidity, density, melting point, boiling point, are the physical properties. What are physical properties? Hardness, color, rigidity, fluidity, density, melting point, boiling point are physical property. Though ice, water, water vapor all look different and display different physical property, they are chemically same because they have same molecular structure. Uh, chemical change bring change in the chemical properties of the matter, and we get a new substance. The chemical change is also called a chemical reaction. Okay, so that means the constant particles, suppose like S2O is this, uh, molecules of S2 will be this. Okay, and it is chemically same whether it is solid, liquid, gas. Chemical structure is same. If the chemical structure changes, the properties will also get changed. Okay, and when chemical change is there, and this is called chemical reaction. When the chemical like chemical, there will be chemical change, like structure of the molecule is changing, then this is called chemical reaction. This is due to chemical reaction. During burning in the candle, both the physical and chemical changes takes place. Can you guess these? Physical change is like it was solid, it will melt into liquid first, and finally to gas. And chemical change will be, I think, when it will burn, it will produce CO2, S2O, and I don't know the chemical reaction, but there will be chemical changes there because it's burning, and burning takes chemical changes. It releases CO2, it releases carbon, black color will be carbon, and Water also releases in burning, though it's not in liquid form, in form of your like gaseous. What types of what are the types of pure substance? Mm, on the basis of chemical composition, substance can be classified either as an element or compound. What are element? Robert Boyle was the first scientist to use the term element in 1661. The element as a basic form of a matter cannot be broken down into simpler substance by the chemical reactions. Okay, the element he defined element is basic form of matter. Element can be divided into metal, non-metals, and metalloids. What are metals? Which have sign, luster, conduct heat and electricity. Ductile can be drawn to wires, malleable, hammered into thin sheet. Like gold is a malleable, ductile is also like can be drawn into wires. Soronovas means sound producing. Soro means sound. These are metals. Into elements are divided into metals, non-metals, and metalloids. We can see the periodic table. Periodic tables has like 110 around 110 elements. Uh, Non-metals. What are properties? There is varieties of color, and metals are not colorful. They are not colorful. Metals are, but the non-metals are variety of colorfuls. Poor conductors of heat. No luster. There is no sign and no sonorous. Do not produce sound and not malleable or ductile. It will break down into pieces when we try to hammer it. Hammer the non-metals. For examples of non-metals, oxygen. Like we forget to discuss examples of metal. Coal, silver, copper, iron, solids. These are the metals. Non-metals are oxygen is there, iodine, carbon, hydrogen is there, bromine and chlorine. Some elements have intermediate properties between those of metals and non-metals, and they are called metalloids. Metalloids are which are in between the property wise in between the metals and non-metals. Boron, silicon, and germaniums are the example. No two more. 92 elements are naturally occurring and the rest are man-made. Okay, I just told you there are at present known as 100 element, more than 100. It is around 105. I don't know the exact number. Majority of the element are solid. 11 are gases at room temperatures. 2 elements are liquid at room temperature, mercury, and 2 elements are liquid at room temperature. Okay. Metal is incorrect here. 2 elements are liquid at room temperature, mercury and bromine, and nothing else in the room. This is a wrong thing which I have written here. Metals. I think mercury is a metal. I think only metal which is liquid at room temperature. It is correct. Compounds. What are compounds? Like elements is like made up of single atom. Hydrogen atom, carbon atom, everything is for single atom. Components. Components is a substance composed of two or more elements chemically combined with one another at a fixed position. Molecules, simply molecules. The substance which is made up of molecules is a compound which is made up of atoms, separately atoms, which is uh, element. Suppose pure gold, AU. AU, there will be AU everything, everywhere. And S2O is a two water and one hydrogen. Sorry, two hydrogen and one oxygen. S2O, S2O, S2O. The bond is not like that, but this is what the compounds where the hydrogen and oxygen forms one molecules, and that one molecules, like separate elements, separate atoms forms together, chemically combines with one another in a fixed proportion, and the substance is formed is compound. Mixture and compound, the difference is element or compound is just mixture together to form a mixture, and no new compound is formed. So like uh, milk is a mixture. The element and compound of just mixture together to form a mixture, just mix together to form a mixture, and no new compound is formed. In water there is a protein, there is a water, there is other things also, and they are mixed well, so they do not form any third compound. That means they are physically mixed but not chemically. They are chemically different, but chemically they are original, na? In compounds, the elements react to form a new compounds. Okay. uh, a mixture has variable composition. Take example of milk again. Milk has water, protein, fat, vitamins, minerals, and all that. Composition of each new substance is always fixed. Suppose water is a compound. Water is a compound. Composition of each new substance is always fixed. And mixture shows the property of constituent substance. The new substance has totally different properties. Oxygen, and when 2H2 molecule combine, it will form a water molecule. And properties of oxygen has different properties, and hydrogen also have a different property. When they will combine and form H2O molecule, they will all together have a different property. And in case of mixture, they retain the properties of the original components. The constituent can be separated easily by physical method, and in this we cannot separate physically, can only be separated by chemical or electrochemical reactions. Electro means electricity. The composition of a compound is same throughout. So again we have another classification. Matter is pure and mixture. Pure substance, element is there only cannot broken down into simpler substances. Compound is have a fixed composition, can be broken down into elements by chemical or electrochemical reactions. Copper, oxygen, iron is a example of element, and component water. Compounds example are water, methane, sugar. Now mixture, no fixed composition. Homogeneous mixture, uniform composition is there. Sugar water, salt water, and sulfur in carbon disulfide. And in heterogeneous mixture, no uniform composition is there. Sand and salt, sugar and salt, and water and oil. Water and oil do not get mixed. Let's revise what we have learned, and we are about to finish this chapter. A mixture contains more than one substance, element, and compound mixed in any proportion. A mixture cannot separate it into pure substance by using appropriate separation technique. Sorry, a mixture can be separated. It can be separated. Can separate it into pure substance by using appropriate separation techniques. Mostly by physicals method are there. Solution is a homogeneous mixture of two or more substances. The major components of a solution is called solvent, and the minor one is solute. The concentration of a solution is the amount of a solute present per unit volume per unit mass of a solution. Colloids are heterogeneous mixtures. They look homogeneous, but they are heterogeneous mixture in which the particle size is too small to be seen, very small, so we cannot see. Too small to be seen matlab uh, they are they are not seen because of too small size with a naked eyes, as but is big enough to scatter light. Particles of a compound are different from the constituent element. Like particles of the compound, like take a S2O, is different from constituent element hydrogen and oxygen. They are different. Where the mixture shows the properties of constituent element or compound. Mixtures like milk shows the properties of water and protein, different proteins, fats, lactose, whatever that is. Okay, here is the end of this chapter, and we have revised it successfully. It's just a revision chapter.